Okay, we're in section 39, which is the section on circles. We covered the lecture. Again, the hope is that you paid attention and made some effort to learn what was presented. Certainly, we'll go through examples now, but the bottom line, hopefully you understand what was presented to you. Mainly that circles have a center and that they have points that are equal distance from that center. And that's a set of points. What we do is we put down 4 characteristic points. That is, we get the center, we move up, we move down, we move left, we move right. Now, how much do we move? The length of the radius, all right? So we have to get our circle in that form where it's really basically related to a distance formula. And the understanding is you need to know the distance formula to understand how it's related to a circle. And a circle is just a set of points that are equidistant from a center point, all right? So we went through the derivation of the formula using a distance formula. Hopefully that's understood. We talked about examples of getting the center and then those 4 character points along the circle and then drawing the picture, of course. Of course, it involves completing the square, which you should be well aware of at this point. We've used that before. We're going to go through examples now. As I do the examples, I'm hoping that what we've talked about will make more sense. All right, so let's take a look. And I'm going to do another share with you. Okay, so we're on example number 1. And let me just, I'm going to pull this graph paper on the side a little tiny bit. And I'm going to blow this thing up here. All right. So the first thing I'll discuss with you is just this circle's in standard form. And what I mean by that, it's written as x minus h squared plus y minus k squared equals r squared. With the understanding the center is h comma k, and the radius is r. Right, I want to point something out to you that h is a number for x, it's the center number, that would make this term here 0. And k is a number that would make this term 0. So let's look at the problem. And I think I can write down my center now. All right, what number here makes this term 0 would be 7. What number here would make this term 0 would be minus 4. That's a center. What's the radius? Well, I'm looking at this number and I'm wondering what square would give me 9. Fairly simple. That would be r equals 3. Whoops. So what I want to do is get my graph paper. I'm going to pull it over. And I'm going to graph the center 7 minus 4. And again, I want to point out to you that's just a point. And what do you mean by that? Let me just pull this down a little bit here. I'm going to pull this over. All right. Let me see if I can pull that graph paper. Just a little bigger here. Let's write down again. So the center is 7 minus 4. This is the center. And the radius is 3. I'm going to go back over here. And when F says what I'm looking for is the center. And the center I have to go 1, 2, 3, 4, 5, 6, 7, and then down 4. Go right there. So I'm going to plot that point. I'll put that in red. And let me just make sure I'm doing that right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. All right, that's done. So I got my center down. Center's done. Now someone says, how do you get the other points? And typically try to use numbers that are really simple numbers. I'm going to put these points in blue. And I'm just going to count 3 units from that center. Now, what does it mean? There's many ways to count 3 units, but I'm saying the easy way is to go to the right, go to the left, go up, and go down. And let's do that. I'm just counting 3 units. That's 3 units from the center, and I'll label that point later. This is 3 units down from the center. This is 3 units to the right. This is 3 units to the left. I'm going to write down what those points are, though. And I'm looking at it, and certainly for some students, it revolves counting. Other students, it revolves around arithmetic. And I'm going to look at this and I'm going to say, looking at it, I know for example, this particular point, the y didn't change. So it's still -4. Let me put this point down. Oops, sorry about that. And what do I know about this point over here? Again, the y didn't change. Let me put this point down and this point over here. Now, what do I know about these 2 points? The x didn't change. Okay. Some students are faster at this than others. So what are you at over here? So I want to point out, when I move in this direction, I'm moving along the x's. And what's the x over here? It's 7. If you move to the right 3, that would be 10. Let's go back over this now. Again, we're talking about the x number, moving in this direction. The x here is 7. And if you move to the right 3, you'd be at the number 4. All right, I want to look at my graph paper and say, some students just by using just graph paper, what do you get over here? 1, 2, 3, 4, 1, 2, 3, 4. So what is it? 4 to the right and 4 down, which is that number over there. If I did this one over here, let me count to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I go down 4. 1, 2, 3, 4. And I'm right there. All right. Again, you can use graph paper to count on. All right, let's do the other one, which is the change in the y's. And I'm looking at it. And again, what I'm pointing out over here is I'm talking about these points here. I'm just moving up and down. Now, from the center, I have to move up 3 units. Well, the y is -4. And if you move up 3 units, you would be at -1. Do the other one. And again, what I'm pointing out over here is you're moving down now. So you're at, on the y value, you're at -4, and you're moving down 3 units. So you'd be at -7. Very simple arithmetic problem. What I want to count is you could still count on is that you can still count there. Let's do that. So 1, 2, 3, 4, 5, 6, 7, and then 1 down. And that seems reasonable. Next one, 7 over, and then it says I should go 7 down. Let's see if that's true. 1, 2, 3, 4, 5, 6, 7. Looks beautiful. Now, what do I want to do? I'm going to ballpark a circle through it. No, we're not looking for perfect. If you want perfect, use a compass. But I'll ballpark a circle through here. Again, I'm not saying it's perfect, but it's certainly, abstractly, it looks like a circle to me. And we're done. All right. So let's go to the next question, which would be number 2. By the way, I want to point out, if you look at the answer key, I tell you the center and radius, and I did put the graph down for you. All right. Let's go to the next question. Next question will be number 2, right? So I'm going to blow this up. And I want to see if I can do it. And this one says find an equation of a circle with radius 3 and center -2, 1. Well, let me write this down for you. The center is -2, 1, which means to me that h is -2 and k is 1. That's the hk. And the radius, it's given to me, is 3. What's the equation of a circle look like? X minus h quantity squared plus y minus k quantity squared equals r squared. Well, I can certainly write this down now. X minus h. Again, I want to point out to you, h is -2. Well, minus and -2 is +2 squared plus y minus k. What's k? K is 1. So I'll write that down for you. R squared. What's r? R is 3. What's r squared? It's 9. This is a fine answer. However, I want to point out, you should have some practice in multiplying this out. Let's go through that. X squared plus 4x plus 4 plus y squared minus 2y plus 1 equals 9. I'm going to rearrange this guy. This will be x squared plus y squared plus 4x minus 2y. Well, the constants does require some work. 4 plus 1 is 5. Take 9 from both sides, and you would get -4. equals 0. Now granted, there's other variations. All I did was I simplified what I initially wrote down. So let's take a look at it and see if we got the correct answer, right? So I'm looking at this over here, and I'm seeing the x plus 2 squared. I'm seeing plus y minus 1 squared equals 9. Let's see if we're seeing the other thing, which is x squared plus y squared plus 4x minus 2y minus 4 equals 0. Right. I also want to graph it just for practice. All right. So what am I going to graph out? I'm going to graph the center, which is minus 2, 1. It should be relatively simple to do. So minus 2, 1. So again, I want to point out, you need to count along the x-axis 2 to the left, and then what? It says 1 up, right? So let me plot that down for you. Right, you need practice at this. What's the radius? The radius is 3 units. What do I have to do? Count up, count down, count left, count right, 3 units. Fairly simple to do. Just looking, I'm going to blow this up now. That's 3 units up. This is 3 units down. This is 3 units right. This is 3 units left. I want to write down the points for you. All right, the center point. What's the center point? Minus 2, 1. I'm going to write those 4 points down now for you. I'm going to write it right next to those points over here. As I do this over here, some students need to count there. That's fine. What's this point over here? 1, 1. Just looking at the picture. What's this point over here? Minus 2, minus 2. Just looking at the picture. What's this point over here? Minus 2, comma. And what would that be? I have to count. 1, 2, 3, 4. What's this point over here? We'll have to count. 1, 2, 3, 4, 5. That's minus 5 to the left, and then 1 up. Right. I'm going to draw my circle in. It's just a ballpark. Again, they didn't ask me to do this. I'm just practicing, and we're trying to encourage you guys to practice as well. All right. Let me talk about if you wanted to just simply do the arithmetic. Now, what's this point over here? It's minus 2, 1. And what do I have to do? I have to go 3 units to the right. Now, if I'm moving left and right, I got to tell you the y wouldn't change. The y is always going to be 1. Now, if you're at minus 2 and you move 3 to the right, that's like adding 3 to minus 2, which will give you 1. If you're at minus 2 and you go 3 to the left, it's like taking 3 from the x. What would you get? Minus 5. All right. Again, the graph paper may be helpful. One is to learn, where the points are. If they're nice, simple points. The other thing is just it's an arithmetic aid for some students. All right. Let's take a look at this one over here. As we move up and down, the x's are not changing, so it's always minus 2. Now, if you're at 1 and you move up 3, well, 1 plus 3 is 4. And if you're at 1 and you move down 3, well, 1 minus 3 is going to be minus 2. So it seems to fit the description. All right. This is good. All right. Let's go to the next question. Give me a second over here. That was number 2. I guess we'll go to number 3, right? Let's take a look at number 3. And I'm looking at it. And this one over here says, find the equation of the circle. And whoops, sorry about that. Find the equation of the circle. I did it again. Find the equation of the circle. Let me push this to the side here. Well, I know what an equation of a circle looks like. And let me write this down for you. It looks like this. Whoops, let's go back to black ink. X minus h squared plus y minus k squared equals r squared. I'm going to read it to you. It says over here, find the equation of circle center. Well, they've given me the center. So this is the center here. This is the center. So what does that tell me? H is 1. And they tell me the k is minus 3. Well, I can immediately write that down. What do you get? X minus 1 squared plus, well, y minus a minus 3 is y plus 3. Now, I'm going to read further, but when I read that, they don't give me the radius. All they tell me is it went through a point. So what it's telling me over here, it's telling me the x and it's telling me the y. It's telling me the x is 2 and it's telling me the y is 1, but they're not telling me the radius. So what do? Plug it in. So let's plug the 2 in. What do you get? 2 minus 1 squared. We'll do the arithmetic later. And what's y? 1. So 1 plus 3 squared. What's that equal? R squared. Let's keep going. 2 minus 1 is 1, and 1 squared is 1. 1 plus 3 is 4, and 4 squared is 16. So I know what R squared is. What's R squared? It's 17. So I'm ready. I'm sorry. I meant to say R squared. 17 does equal 17, by the way. Let's write our equation down now, right? What's it going to be? X minus 1 squared plus y plus 3 squared. And what's R squared? It's 17. I'll put a box on it indicating it's an acceptable answer, but I do want to multiply it out. And what do you get over there? Sorry about that. You get this. X squared. Whoops, I made a mistake. I'm not thinking. X squared minus 2x plus 1. So what'd you just do? I squared that. Now we're going to square this guy. And what do you get? Plus y squared, right? Plus 6y plus 9. What did I do? I squared this guy. Now what do you get? Equals 17, right? All right, let's keep going. X squared plus y squared. I just did these two. Minus 2x plus 6y. We'll look at the key later. Then we get, 9 plus 1 is 10. Take away 17, you get minus 7 equals 0. All right, I will look at the key. I want to see if I got it right. And I'll get it out. X minus 1 squared plus y plus 3 squared equals 17. Looks good. Let's see if we got the other one. X squared plus y squared minus 2x plus 6y minus 7 equals 0. I want to point out for some students, graphing this thing is going to be rather difficult. All right. However, it could happen, but I want to go through it with you. All right. And someone says, why do you want to go through that with you? Well, we're trying to move you forward, and not all numbers are going to be finger numbers. And there's a case over here where I got some troubles over here. And let me just see if I can, and I got this all screwed up now, don't I? Let me see if I can get this unscrewed up. And let me just see what's going on here. I'm going to pull this piece of graph paper over and blow it up. And it's tough. By the way, I know they didn't ask me to graph it, but I still want to go through the graphing of it. Now, what I'm trying to get across over here is that not all numbers are nice. All right. I think I should treat them equally, though. And what do I know? I know the center of this circle. And what's the center of the circle? Well, the center of this circle is 1 minus 3. They're nice numbers, by the way. They're really simple numbers. Now, what else do I know about this circle? I know the radius. And the radius is going to be actually the root of 17. All right, this is where the trouble comes in. A lot of students look at this and say, I really don't think I could do that. My claim is you can do it. Root 17 is like any other number in the universe. All right, so I'm going to go plotting this guy if I can. I'm going to put the center down first. And this is where a lot of students really, they kind of mess up with it. And if you got the center wrong, everything in the problem is going to collapse on you. I make mistakes too. I'm not saying I don't. So 1 minus 3. Oops, sorry about that. I'll jump you over there. So I'm going to say that was pretty easy to do. I want 1 to the right and 3 units down. Now here comes the tough part. And the tough part is the root of 17. You should have some idea the root of 17 is 4 point something. So again, you should have a rough idea that the square root of 17 is 4 point something. So what I want to do is just look at my picture, and I'm not saying I'm getting it exactly right, but I'm going to do 4 point something. All right. So I'm going to move up 4 point something units over here somewhere. Then I'm going to move down 4 point something units. Again, someone says, I don't know if that's accurate or not. I'm just ballparking. I went down 4 point something units. I'm going to move to the right 4 point something units. I'm going to move to the left 4 point something units. Here comes the tough part. I got to get those points. I'll write them down one at a time, and it's going to look nasty. Okay, let's look at this point here first, this blue point over here. All right. One thing I know about this over here is the y didn't change. But the x, I was at 1, and then I moved over root 17. So it's going to be 1 plus root 17. All right, let's do the other point. So what other point you do? I'm going to do this one. And what's that point going to be? I'll write it down for you. Now, what do I know about that? I know the y didn't change, so it's y still minus 3. But what did I do? I moved left from 1. How much? Root 17. So 1 minus root 17. All right, I'm going to move up and down now. And if I move up and down, the x is not changing. And again, for some students, this takes a lot of effort to think through. Take the effort to think through it. I really mean that. Now, you're moving up from minus 3, root 17. So what's going to be? Minus 3 plus root 17. I moved up root 17. What's the other point going to be? Well, I'm moving down from minus 3. How much? Root 17. All right, what am I going to do now? Draw my picture. And again, I'm not saying it's going to be a perfect circle, but it's good enough for our purposes over here. All right, and that's my circle. All right, that's my circle. Okay, let's go to the next question. Again, they didn't ask to graph it. I'm just practicing. That's all I'm doing. All right, number 4. Now, number 4 wants me to get this equation to standard form. And someone says, what's standard form? It's always going to be the same thing. It's going to be x minus h squared plus y minus k squared equals r squared. So let's go through it. Well, I'm going to get the x's together. So it's going to be x squared minus 2x plus y squared plus 12y. And I'm going to put the number on the other side, which is minus 12. All right, let's see if I did that right. X squared minus 2x, I definitely see that. Y squared plus 12y, I definitely see that. And I subtracted 12 from both sides, and I see that. All right, what am I going to do now? And this is the part where your prior experience can be helpful. The coefficient here is 1, which makes completing the square very easy. And you take half of that number, which is minus 1, and you square it, which gives you plus 1. So what do? I'm going to add 1 to both sides. All right, let's keep going. And the coefficient on this y squared is 1, which is great news. And I'm going to take half of that number. I'm going to complete the square, which would be 6, and square it, which will give me 36. And I'm going to add 36 to both sides. All right, I'm going to write this down. There's 2 perfect squares now. I'll push this up. It's going to be x minus 1 quantity squared. That would give me this guy over here, plus y plus 6 quantity squared. That would give me this guy over here. And what do you get on the right side? Well, let's take a look at it. Looks like you get 25. I'll write that down for you. All right, I think I'm ready to write down the center and the radius now. So the center well, what makes this thing 0? 1. Put that down. Comma. What makes this 0? Minus 6. Okay, radius, fairly simple to put down, especially for this problem over here. It's going to be 5. And why is that? 5 squared is 25. All right, so I put it in standard form. I got my standard form, and this is the standard form over here. I have my center and I have my radius. I want to graph it. All right, let's see if I have any graph paper left. Yeah, I do. It's over here. Let me see if I can, whoops, sorry about that. You know what? I have to get a new piece of graph paper here. Let me see if I get some. Oh yeah, I got some over here. I'm going to copy this. Over here. And I think I'm doing this one here, right? Yep, doing this one here. So I'll pull this down here. Blow this thing up. We're going to do one thing at a time. So suppose what are you going to do first? Well, I want to plot the point. What point do I want to plot? The center. And what's that going to be? 1 minus 6. Again, if you have graph paper, it should be relatively easy to do that. It does require counting though, but it's not a lot of counting. All right. So the question is, did I move 1 to the right and 6 down? Well, let's take a look at it. 1 right, 1, 2, 3, 4, 5, 6. Now what do I have to do? I got to do a radius of 5. And I really do believe it's easy to do if you can count. That's 5 up. That's 5 down. That's 5 to the right. That's 5 to the left. I'll label those points in a second, but I'm going to ballpark my picture in now. And again, I'm not a great circle drawer, and you don't have to be. Put this over here, and I've got to put my points down now, right? And this is the 4-point technique. Fairly simple to do if you've been paying attention. All right, so I know my center is going to be 1 minus 6. So this point over here, I'm just moving up and down. The x is not changing. When I move left to right, the y's are not changing. So that's minus 6. And you can verify that by looking at the picture. Now I'm moving up from the center, and the center is 1 minus 6. And if you move up 5 units, which is the radius, you'd be at minus 1. If you're at minus 6 and you move down 5 units, you'd be at minus 11. All right. Now let's move left and right. And you're at 1, and if you move right 5, you'd be at 6. If you're at 1 and you move left 5 units, you'd be at minus 4. And again, you can verify that by counting those points if you like as well. All right, so I'm going to say we're pretty much done with circles. There's not much else to say about it. Typically use very easy numbers. I think the worst number we saw today was the root of 17. And root of 17 is really not that bad. It's roughly 4. And why is that? 4 squared is roughly 16. It's bigger than 4, certainly. Make sure you practice. And what are you going to practice now? The homework. You've got to do those supplemental activities, including the WebAssign. Thank you for your attention.